Welcome everyone to my presentation. I am Léonard Vincent from University of Lausanne. What I am going to talk about is based on a joint work with Hans-Jörg Albrecher and Yuri Krivavi. In this presentation, I will show you that it may be interesting to index a reinsurance treaty on the relative performance of the insurer buying that treaty. And this presentation has three parts. In the first one, I will explain and motivate the topic. In the second part, I will quickly show you some theoretical results, and finally, I will illustrate these results with a concrete example. So first of all, consider an insurer with X being the random total claim of its policyholders, and PX is the related total premium. In order to manage its risk, the insurer can purchase a reinsurance treaty under which it will cede a part Fx of its total loss to a reinsurance company. Fx is thus called the ceded loss, and it is computed using the ceded loss function f. So f is the rule determining the amount to be paid at the end of the year by the reinsurer for each possible realization of x. In standard reinsurance treaties, the ceded loss depends only on the aggregate claim, but in some contexts, this can be viewed as inefficient. Indeed, the insurer's need for reinsurance may not only depend on its insurance loss. For instance, a car insurer will clearly expect to need more or less reinsurance, whether a hailstorm occurs in its geographical region or not. So let's reformulate it with the appropriate notation I will use. Say that Z is a random variable modeling the future risk environment of the insurer, and the values it can take are mutually exclusive risk scenarios. Then the drawback of standard reinsurance is that the ceded loss F does not take into account Z. Considering this, insurance companies sometimes purchase reinsurance treaties that are made dependent on some random variable related to their risk environment. Under such a treaty, the loss that is ceded to the reinsurer will not only depend on the total claim X, but also on Z. And in that case, we denote the ceded loss Fz of x, and thus f with index small z is the ceded loss function applying in the case the risk scenario small z realized. Coming back to the example of the car insurer, an indexed reinsurance treaty would be, for instance, if there is a hailstorm, then it cedes 40% of its total claim to the reinsurer, and otherwise only 20%. In this paper, we call this type of reinsurance indexed reinsurance, but depending on the context, it has been called differently. For instance, in these papers, it appeared as double trigger reinsurance, random reinsurance, or multiple indemnity environments risk sharing. In our work, we wanted to determine whether indexing reinsurance on the relative performance of the insurer was relevant or not. Here, the relative performance of the insurer has to be understood as its performance compared to those of the other insurers in the same market. We came to this idea for three main reasons. First, the relative performance will be in general nicely correlated to X, which means that depending on Z, the insurer will expect larger or smaller X, and thus it will expect to need more or less reinsurance. The second argument is the following. So, if an insurer is the only one in the market to incur large losses, this will send bad signals to its stakeholders, and it may thus trigger an episode of financial distress. During such episodes, many important things for the survival of the insurer become more expensive, such as, for instance, raising new capital or acquiring a new business. Some expense will necessarily result from this, which has been pointed out earlier in the literature, for instance, in these two papers, and we called this expense the costs of financial distress. And since these costs are typically triggered by the occurrence of a bad relative performance, they are a strong additional argument in favor of making the extent of the reinsurance depend on the relative performance. Finally, the reinsurer may also benefit from this. Indeed, it is in general very unlikely that many participants of an insurance market face at the same time a bad relative performance. Therefore, if the reinsurer sells treaties indexed on the relative performance to several insurers in the same market, then it might benefit from some degree of hedging. So this sounds interesting, but there are two things that need to be determined before going further. First, what kind of indexed reinsurance treaty should be picked, and in order to assess whether the indexed reinsurance we picked performs well or not, what can we benchmark it with? We will somehow stick to the traditional approach to these problems. We defined a minimization problem under which we determine the optimal reinsurance treaty, both when indexed reinsurance is considered and when it's not. And we will compare the results to quantify how well indexed reinsurance perform. But before talking about the optimization problem, here is the related framework. So we assume that the insurer computes its total risk for each risk scenario using the value at risk. Thus, for risk scenario small z, the total risk amounts to the conditional value at risk of the total loss faced by the insurer, which is the retained insurance loss, this, plus the financial distress cost. We denote the worst case scenario z hat, and it is simply the scenario for which the total risk is the greatest. And T0 is simply the total risk when there is no reinsurance. We assume that the insurer computes its capital requirement in a cautious way, that is, as the total risk under the worst case scenario minus the retained premium. Also, we assume that the financial distress costs are a function of the loss retained by the insurer and the relative performance with these two properties here. We assume also that reinsurance is priced according to the standard deviation principle, and hence this here is the standard deviation. Finally, we only consider the ceded loss function that belong to this set of admissible candidates. That means that the insurer will never cede a negative amount, nor it will cede an amount that is greater than the total claim being reinsured. And this condition here ensures that for each risk scenario, none of the two parts of the treaty has an advantage of the total claim to be greater, which is a classical condition since it reduces moral hazard. So now here is the optimization problem. We minimize the reinsurance premium under the constraint that for each risk scenario, the total risk does not exceed K, and K is a positive value that is arbitrarily chosen by the insurer, taking into account solvency capital considerations. One can show that if the parameter theta in the premium principle is not too large, so under this condition, and COV is the coefficient of variation, then the optimal reinsurance treaty is an indexed bounded stop loss. The corresponding ceded loss function is this one, which means that if the realized risk scenario is small z, then the reinsurer will pay everything that is between dz star and dz star plus lz star, with dz star and lz star being the deductible and the limit of the bounded stop loss for risk scenario z. The deductible and the limit are thus function of the risk scenario z, and of course they depend on K and on the other model inputs. Okay, so that was for the optimal treaty when indexed reinsurance is considered. But when it's not, then the optimal standard reinsurance treaty will simply be a bounded stop loss with the ceded loss function being the one from the indexed bounded stop loss, but for the worst case scenario only. Okay, so now let's illustrate this with a concrete example. The model inputs are the following. We consider a market with two insurer competitors, and each one has a total claim with a Pareto distribution starting at 0 and with scale parameter 1 and shape parameter 2. So that the expected total claim is 1. We assume a Clayton Copula for the dependency between x1 and x2 with parameter 0.5 and right tail dependency. The performance of each insurer is modeled with the loss ratio, that is, the total claim divided by the total premium, which we set above the expectation to 1.2. The relative performance is defined as the indicator of that event, which means that for each insurer, if its loss ratio is greater than 2 times the loss ratio of its competitor, then it realizes a bad relative performance. And with the inputs we assume the above, the parameter theta in the premium principle is 10%, and the total risk is computed using the value at risk at 99.5%, as it would be under Solvency II regulation. Regarding the financial distress costs, we assume that the function G is such that if there is no bad relative performance, then there are no financial distress costs, and also the financial distress costs are at most equal to the half of the capital requirement. And now let's move to plots and results. So here I drawn a bivariate random sample from the Clayton Copula, and you can see that it is mostly independent and it has only a right tail dependency. On this plot, you have the reinsurance premium for all possible K, And remember that K was the value to which the insurer decides to reduce the total risks. So the blue curve is the reinsurance premium for the optimal standard reinsurance, and the yellow one is the reinsurance premium for the optimal indexed reinsurance. And as you can see, the blue one is above the yellow one, so that using indexed reinsurance reduces the reinsurance premium. The green curve is the improvement in percent, so you can see that in most cases we are around 20%, which is very good. Okay, so that was for an insurer, but finally we wanted to compare standard and indexed reinsurance from the reinsurer standpoint. Let me explain how we did. So for one reinsurance treaty, the expected profit of the reinsurer is the reinsurance premium minus the expected ceded loss. And if we normalize this taking into account the volatility, then it's simply 10%. And you can see this as some kind of a Sharpe ratio. Okay, so that means that the expected profit of the reinsurer relative to the standard deviation is 10% for any standard or indexed reinsurance treaty. And this is for one reinsurance treaty. But now let's assume that the reinsurer sold reinsurance treaties to the two insurers in the market. The expected profit will thus be the sum of the two individual expected profits, and the expected profit relative to the volatility of the two ceded loss will be this formula here, and since it is equal to the sum of the standard deviation divided by the standard deviation of the sum, the smaller the dependency between the two ceded losses, the higher this will be. So we are going to use this quantity to compare the situation of the reinsurer with standard and indexed reinsurance. And here are the results. So in blue, it's the relative total profit for the standard reinsurance treaties, and in yellow, it is for the indexed reinsurance treaties. The reason why both curves are above 10% is because of the diversification effect of taking into account two ceded loss. And the most interesting part is that the curve for the relative total profit under the indexed reinsurance treaties is strictly above the one under the standard reinsurance treaties. And in green, you have the difference between the two curves, and as you can see, for most relevant case, it's around 3%, which is good. So now a very quick conclusion. First, we have seen that in our example, using the relative performance allows us to substantially reduce the reinsurance premium paid by the insurer for the same level of safety. The reduction was 20%. And even better, we have just seen that this is not at the expense of making the situation of the reinsurer worse. On the contrary, the reinsurer also ends up in a better situation. Based on this, we think that using the relative performance in indexed reinsurance definitely has some potential, and we will try to show in the future that this also holds for different framework and with a bigger insurance market. Thank you for your attention. And finally, here are the references I mentioned in this presentation.